so let's talk about modeling. Actually, when I was at the University of Arizona, somebody joked with me that I guess some bigwigs from the Department of Defense at the time had come in and they had seen on the agenda that they were going to talk about the various models that they had. And so they came in and they said, well, can you bring out the models? You know, thinking like it was like fashion models, but they were disappointed. So we're not talking about fashion models here, obviously. We are talking about having things in the real world that we want to simulate or kind of capture. So if you think back to math classes when you were younger, I'm generalizing here, but bear with me. Word problems. You know, when you had a word problem, you had to figure out what variables were actually of interest, and then how to develop those variables into some kind of model that you could then solve. So that's basically what we're talking about here when we're talking about modeling a problem. It's more difficult because the space is kind of unexplored, and your teacher hasn't just said, okay, here's the formula, figure out how to get the variables, and then plug it in. So, but an interesting thing about models, so there are a lot of different types of models. This is what I would consider to be a theoretical model. So it shows you, we're looking at some kind of house. It doesn't give you too much detail, but it shows you the basics. So where each room is, the size of each room, and so on. So this is kind of rudimentary. We can also look at this kind of model, which is a step up from that. So getting a little bit closer to actually the practical problem space. And finally, something like this, which really goes into great detail about what's happening in the space. And so in your travels through analytics and the different techniques that you'll learn, you'll have this type of model and you'll have the more kind of theoretical, loose type of model. So it just depends on what problem you're solving. So. Okay, so in analytics, what we're talking about really first is how to choose the right variables when you're considering modeling the problem. So I'm trying to think of a good example, because we will be doing linear regression eventually. I actually have an example coming up, so I'm going to hold that thought. So the statistician George Box said all models are wrong, but some are useful. And this is just to say that basically, even if you have a mathematical model of something in the real world, it's not going to be exactly correct. So, right, there's going to be some wiggle room. When I was working on my dissertation and we were modeling perceived exertion for bicyclists, this was very true. Because maybe for one expert, they feel this incline a little bit harder than another expert, even though we kind of group them all together. So you have to make a lot of assumptions when you're working with models. Okay, so let's take a look at an example. So we are considering the problem of family income and basically how to predict what a family's income might be. So you can see in the slides, but just from the crowd, what kinds of variables might you consider when trying to predict a family's income? What do you think goes into it if you had to start from scratch? Don't be shy. You guys are new, so would it help if I gave extra credit or something if you raise your hand? Oh. Yeah, factors that go into a family's income. Yeah, and tell me your name again. Sorry? Oh yeah, you just came in. Lakshmi. Do you go by Lakshmi Priya? Yeah. Okay. Yeah, go ahead. And you don't have to stand up. That's not necessary. Yeah. Go ahead.
Family income depends on number of members in the family. And
sure.
what type of employment he does. He or she does.
Okay, yeah, so members of the family, type of employment. Okay, others. You guys are real shy. That's okay. Well, I don't have any children, so I get to keep, a lot of that money for myself, right? So things like that. Let's take a look. I'm gonna skip back here. So some things we can consider. Age. So maybe you consider that if a person's been around longer, and again, this is generalizing, which is why we talked about models not being completely accurate. But as people get older, they probably have been with their jobs longer. That is changing. But so that might mean that they make more. Level of education, affects that as well, which again, not always. But marital status. So if you have two people, or contributing, that might be more than say one person. And then the number of full-time employee family members. So this is the exercise we're kind of going through here is just talking about how to develop a model. So, and it is a process. Once you get to the business analytics course itself, you'll see how to start with a multivariate, which is what this is, statistical model, assess how good it is using things like R-squared and some other factors, and then see how to revise that model until you get to one that's really strong. But this is our first stab at this. So we're saying these are the variables that contribute to family income. When we talk about this kind of modeling, and again, this is probably something you already know, but just as a review, that our target is we want to predict family income, so that is our dependent variable. Versus on the other side, we have our independent variables. So if we were going to run a regression, which we will later, we would put all of these into the model and have this as our target, and then see kind of what comes out of it. So for those of you that have you guys have done statistics before, what kind of software have you used for that? You just say out loud. Statistical software? What do you guys? What's up?
Y equals to MS plus C.
Oh no, I mean like what computer program?
Okay.
Yeah.
Excel.
Excel? Okay.
Tableau.
For statistics, really?
No, not for that.
Yeah, we're gonna do some Excel. But there's also things like SAS, SPSS, Minitab. It's a lot of different statistics software. So. Okay. So as we're developing this particular model, we could say, if we were writing this up, that family income is influenced by age, education, marital status, and family employment. So this would be our first take on this. So, because like I said, I'm going to skip back to here. In our first conversation, this is a good framework, but it doesn't have to be steps 1 through 6 and no variation in between. It might be that after you actually conduct the analysis that you want to revise your model, or that you need more data to supplement it. So this is kind of the iterative process right here. All right. Okay, so just to hopefully stimulate some discussion amongst yourselves, let's take another example. So let's try to develop a model for determining whether or not you should get a pet. Okay, so the question is, should I get a pet? Let's just leave it at that for now. Don't worry about which kind. So should I get a pet? So kind of take a couple minutes, either by yourself or talk amongst yourselves, and think about what variables you would consider, including what your target is, and then how the variables might be related. So things that you would consider. So then I'll ask you to. Go ahead. Thank you.
पेट है, अब पेट लेना है, तो उसके लिए क्या क्या चीज़ें अपन कंसिडर करके पेट लेना
No, I know. Now I'm trying to. I was actually is that right? That's actually what I was going to say. It's very I'll be done in a second. I'm just coming around. Yeah, so.
ग्रेड देखते हैं डिपेंड इस पे चीज़ है
And you are. Yes. Have it.
Yeah, this is Aves. Yeah.
Okay.
The first name is Aves. We already texted.
No, I know. I'm trying to remember now. Yeah.
This is Aves.
All right. Okay. So thank you as I attempt to learn your names. So what are some of the variables that you consider when deciding if you're going to get a pet? And you can just shout them out. That's fine.
Type of pet.
Type of pet? Okay, so type of pet. What else?
You see the age, lifespan.
Age of pet, okay.
If the area is suitable.
Area is suitable.
Food habits.
Sorry?
Food habits.
Say that one more time.
Food habits.
Oh, food habits, yeah. So what to feed the pet.
What he likes and what he dislikes. Lifespan.
Lifespan, okay. Of pet.
Type of breed.
Cost of living.
Cost of living, okay.
Time investment.
Time and yeah. Investment, okay. Hygiene. Yeah. I had rabbits once, that was a mistake. So and guinea pigs. Anything else? So we didn't. You guys are cost of maintenance. Okay. There are charts on that too, actually.
It's lifespan.
Lifespan, yeah, I think we got, did we get lifespan? Oh, I said age is, okay, no, but I'll include lifespan, because we have a discussion to have. Other things.
Medication and vaccinations.
I'm sorry,
Medication and vaccinations.
oh, medication, yeah. Okay, let's stop there and just kind of think about this. So, again, you guys have had statistics, but you could probably use a review. So, are you familiar with the concept of heteroskedasticity? Have you heard that word before?
Excuse me?
Heteroskedasticity. Okay, well, we're gonna do a statistical review. Yeah, you've had my analytics class, yes, so you know what it is. So we'll leave that at that for a second. What about variance inflation? You know variance.
Yeah.
Yeah. So, and what is variance? Variance is yeah. So variance is how much the dependent variable is affected by a change in the independent variable. So if, like we said, more education, so education increases, family income probably also increases. So that's referring to the variance. Now, the thing about a good model is that it is what we call parsimonious, which is another big word. I'm not trying to make this more difficult, but parsimonious means it's saving money, saving space. So you want to be as minimal as possible. So I bring this up because we have all these variables. This is nice, but some of these variables are actually directly related, right? Like, for example, things like medication, vaccines probably factor into cost of maintenance. Cost of living is probably related to area that's suitable. Lifespan and age are directly related. So I bring this up because when you're thinking about variables, you also want to consider kind of, and that was the point of this exercise, but you want to consider which ones are actually going to explain changes in variance the most, which is related to that concept of R squared. So if we were to take all of these and shove them into a model, we'd probably get a very high, I keep saying R squared, basically a very good model where, such that all of these independent variables really do have an effect on the dependent variable. But what we would find is that we would have variance inflated. Basically, we'd be adding to the variance explained because we have all these closely related variables. So that's something we'll talk about once we get there. As well as, I guess, sometimes I like to sit, but there's so many of you, it just feels weird to sit down. The other question is, we didn't really talk about this. Should I get a pet? If we're trying to mathematically model this, there are like two answers, right? It's either a yes or a no. I guess my question is that our dependent variable? It's not a trick question either, whether or not we should get a pet. What would be our dependent variable? It could be, but that would make life difficult because that is not a continuous variable. We're going to talk a little bit about that today. Should I get a pet? Answers are yes or no. That's binary. It can be done with a regression, but it's difficult, which that's the other thing we'll start to talk about is how understanding your data will help you understand what techniques you can actually use to process it. But another consideration is maybe we have a rating, like a suitability rating, that's affected by these variables instead. And that way we could kind of run the regression a little bit easier. So let me. But does that make sense in general? Ish. We're kind of just talking in general about framing a problem and some of the issues that can come up. So how are the variables related? Well, basically we'd have to pick a dependent variable and then pick initial dependent variables to impact that. Now some of them, some of them are very subjective. Right, that's going to be up to you. Like the age of the pet, maybe somebody really likes having a senior pet and somebody doesn't. So another factor to consider. Here are some other examples of variables, leaving the pet example behind. So things like number of days, price, usage, performance, kind of talking more about business. Demographic categories like gender, race, ethnicity, and perception. So things related to products, purchases, brands, and satisfaction. So you've seen a lot of data, and you've likely seen these things as titles of fields. But now we're really going to start thinking about, okay, what do I have? What am I looking at, and how can I put that into a model? Okay. So let me see where I'm at. Yeah. Have any of you conducted a survey before? Some of you have. Some of you have, and some of you haven't. Yeah. Have you? Well, you've probably taken a survey, maybe against your will. And then, have you ever created a survey? Some of you have. Okay. All right. So I bring this up because it's going to segue into our discussion of data. Let me double check on my. Yeah. Okay. Okay. So if you've made surveys before, or have at least taken them, let's talk a little bit about types of questions and types of data that can fit those questions. Okay, so this is a survey related to food and food preferences. So this first one, please describe your favorite style of food. What kind of data? Sorry, descriptive? Oh, what did you say? Descriptive, yeah, so it'll be descriptive. What other kinds of things can we say about the data that would go into this box? Sorry, I'll come over there. And now I feel like I'm just intimidating here. Which you guys are like the most. I don't know if I'm scared. I really don't think I'm scary, but anyway.
Qualitative.
It is. Sorry?
Qualitative.
Yeah. So qualitative data, right? Unless somebody just weirdly types a bunch of numbers in the box for some reason. So yeah, this is an open-ended style question. We would gather. It's almost like an interview. Good thing. Think of it that way. If you're wanting to conduct qualitative analysis to get more kind of richer data out of it, this is when you would use a box. Qualitative data is, I would say, more difficult to work with because it is so subjective. I've done a little bit of qualitative analysis, and it takes a lot more time. But you get a lot richer concept of what you're dealing with. You know, because somebody can really describe not only what you might think of, like, do you like barbecue, sushi, Indian food, Chinese food? They can tell you all of the details, right? So you're not putting them in a box asking them. So another type, is sushi one of your favorite foods? Yes or no? So what type of data is this? So this is going to be quantitative data, yeah, because we have a yes or a no. It is quantitative, however, it is also categorical, because we have two categories. It's either a yes or a no. So we would have to dummy code this into like a 1 and a 0, something like that. Yeah, it's binomial, and work with it from there. Okay, which style of food is your favorite? So this is again going to be, this is also quantitative, but and it is categorical. So we'll get to the specific terminology later as to what it is. We're thinking of the two terms are nominal and ordinal. So this is nominal data. It's unordered categorical data. Okay, next we have, for each of the following types of food, please rate how strongly you agree that it is delicious. So where 1 is strongly disagree and 5 is strongly agree. Also quantitative, but now we're on a scale. So because we have this ordered scale, this is now ordinal categorical data. Okay, what is your favorite food type in order of favorite to least favorite? So this is one where you can actually drag and drop. This is just kind of also to show you all the different kinds of questions that you can have. So still have categories, but now instead of being nominal, they are ordinal because we're actually putting them in an order. Rate how much you love barbecue on a 0 to 100 scale. This data is actually easier to work with because it's now almost continuous in a way. So the two types of continuous data are interval and ratio. So this would be interval data. You get a hard score out of this. That's very easy to play around with when you're doing statistics, for example. The other thing I want to mention about surveys, and just I guess if you've dabbled in user interface design, when you're thinking about how you want to pose a question, that's actually very important because what if instead of the scale, I just had a comment box where it said rate from 0 to 100, you know, what it was? What could be a potential issue with that? So as opposed to the scale, I just have a box where it says, you know, put 0 to 100 in there. Oh, it actually took that. It shouldn't. My point being that, okay, with something like this, when you're asking for a specific type of data and you want that from the user, the slider is nice because it will actually lock that in. They don't have an opportunity to say type in a box like some nonsense like I just did. Although I don't know why it accepted that. I wonder what it will say on the back end. But that's why, you know, when you're filling out sometimes credit card information, will have a drop down for the month. So you actually select it rather than typing it in. So it just avoids errors like that. Okay, how many times you've eaten each of these styles of food in the last 3 months. So this is actually going to be continuous data. So, and it will be interval. We can't have anything less than 0. Okay, and then finally, what is your age? We have the box. This is also quantitative data, but we've allowed for mistakes. Okay, so just kind of to demonstrate that when you're crafting a survey, you want to make sure you limit what they can actually put in so that it works properly. Okay. Trying to decide if we should take. We haven't been at this that long. Okay, you don't need a break yet, right? Or you're okay? Or you want to take a quick break? You're good? Okay. All right. In that case, okay, so let's talk a little bit more about data. Which again, this class is just a little strange for me because it's less technical, but we'll see how it goes. So the importance of talking about data in general and being able to look at a piece of data and categorize it then helps you figure out what you can actually do to that data. Because as I was mentioning before with the pet problem, how you frame that in terms of your dependent variable is very important. If your target is a yes/no, that's going to really affect the types of analysis that you can do versus, say, a scale. So the first step, and you'll do this in the business analytics course as well, when you are thinking about solving the problem, is to, once you have your data, figure out how to categorize that data so that you actually know all the things that you can do to it. So introduction to data, we've already talked about data quite a bit. Collection of facts obtained as a result of experiences, observations, or experiments. So we looked at survey already. You can also, of course, pull data from a secondary source, like online data. There are a lot of good sources, which I will show you. So talk about different types. It can be numbers, words, images, audio, all different kinds of things. And then it's the lowest level of abstraction. So say one transaction, how many, the fact that one soup can was sold to a particular customer in one day. We use it to generate information and knowledge. And of course, the quality and integrity of it are critical to analytics. So in that step where you're actually doing the data collection, that's where you want to make sure that your data is both reliable and clean, which you can do a whole course on data cleaning, honestly. Okay. So this is just to illustrate all the different places that you could get data potentially for the purpose of analytics. So business process data in things like a customer relationship management system, supply chain management system, social data from the web, Internet of Things data, and so between here and actually processing the data, you would have to store it, protect it, and clean it. Okay, we've kind of already touched on this a little bit, but you really want to make sure that your data is clean before you do your analysis. So it's less important as to what we're doing today. Okay, so let's look at taxonomy of data. So, and we're going to break down all the different types of data that you can look at, which I kind of already referenced. So you have structured versus unstructured or semi-structured data. Those are kind of the first general categories. With unstructured data or semi-structured data, that's things like text. So if you were conducting an interview, for example, or you used comment boxes in a survey, that would have to be coded before you could work with it. You'd have to say, okay, the person mentioned soup. I don't know why soup is in my mind, but the number of times they mentioned soup, then we could actually put that into some structure, if that's what we were interested in measuring. Similarly, with things like multimedia, there's a whole area of research surrounding taking images, audio, video, and turning it into workable quantitative data. That's been going on for at least 10 years. And then things like XML or JSON data, that has some structure to it, right? So if you write an algorithm, you can quickly process what's on a page. But ideally, you have structured data. So data that is quantitative in nature and falls under one of two categories. So either it is categorical or it is numerical. So we'll give examples of each of these. So for categorical data, it's either going to be nominal or ordinal. Numerical, it's either going to be interval or ratio. So let's take a look at some examples. Okay, so we're going to start with categorical data. So for categorical data, I said it's either nominal or ordinal. So here's an example of nominal data. We have categories of food at the grocery store. So just kind of take a look at that for a second. Is there any particular order to this data? We have the categories of canned, frozen produce, and dairy. Is there any order that's natural to this data? See some of you shaking your head. Maybe. I don't know. You tell me. Is it obvious or no? Yeah, it's not ordered, right? There's no. I mean, you could impose order on it by saying like I'm going to put it in alphabetical order, but as it stands, they're just categories that exist. So categories that are unordered, that's nominal data. So things like, yeah, things at the grocery store, categories of games, genres of movies. There's no inherent order to that. Okay, next, if we have categories that are ordered, then we have ordinal data. So that there is, for example, like a Likert scale from 5 to 1, strongly disagree to strongly agree, 5, 4, 3, 2, 1. So that becomes important when you're doing the dummy coding in the statistics as to how to represent the different categories. So, which we'll hopefully look at once we get there. I think it's week 7. Need to double check. Okay, so moving on to continuous data. So there are 2 types of continuous data, interval and ratio. This is where it gets a little bit tricky. So I'll just read the definition and then kind of talk about what that means. So for interval data, it's where the interval to every point of measurement is equal to every other, and 0 does not indicate an absence of the thing that you're measuring. So the interval of every point of measurement is equal to every other, and 0 is not an absence of what you're measuring. So a good example of this is time of day, right? Because hours are the same distance apart. If you're using the 24-hour clock, 0 doesn't mean you have no time. It is a specific time. Trying to think of another example of. What's up?
Measuring temperature.
Temperature, yeah, temperature is another example. So because 0 is not an absence of temperature, it's just the temperature, right? A good example. So interval, the real key is that 0, it has meaning in itself. It's not just nothing. As opposed to ratio data, which this is the easiest type of data to work with. You can do pretty much anything to this type of data. So it's numeric data that has a meaningful 0 point. So things like height, weight, age, income, money. So where typically negative values will not be permitted. So, or negative values will not be permitted because 0 is an absence of the thing. You don't have negative height, weight, age, or money. Okay, so let's take a look at these and see if we can identify what they are. So let's take item first and just the item itself, like oranges, apples, mozzarella. So of the 4 types that we just talked about, what type of data is that? So the 4 types are nominal, ordinal, interval, and ratio. Nominal? So yeah, go ahead. It is nominal, so can you explain?
It doesn't have an order.
Doesn't have an order, and it's not numeric, right? Also,
Okay.
so it's category. So those kind of 2 things. So there's no order, and it's not numeric data. What about section? Similar. What's up?
No.
Yeah, so it's tempting to say it's ordinal because there might be some order to it in the store, but that doesn't affect how you process the data. So this is also nominal data. the categorical data that has no order. What about aisle? This one's a little tricky, actually. So let's start at the top. So is it, first of all, is it categorical or is it continuous? Or, yeah. So why would it be continuous? It is a number. However, this is where it gets tricky. Because just because it's a number doesn't mean that that number has that kind of numerical meaning. Right? Like if you think of, say I coded level of income 1 through 5. Those numbers, just because they became numbers, doesn't make them continuous data. It's still categorical data because the numbers are representative of a category. So in this case, I guess it depends on how you look at it. So aisle, it is categorical data because it's not the number. It's not like a quantity of something. It's just a demarcation of which aisle the item is from. So as to whether or not it is ordered, I think that's up to opinion. So if for the problem that you're working on, the order of the aisle matters, maybe it's like some kind of distance optimization problem, then it matters. If it's just where the food came from, then you would consider it to be, again, just nominal data. So, yeah, so be aware of that when you're working with numbers, that sometimes numbers are just categories. Okay, quantity, moving on. Ratio, yeah, because it's numeric and what about 0? Yeah, 0 is an absence of the thing. Yeah, that one's easy. And cost? Yeah, cost is also going to be ratio data. Yeah, because 0 is $0 and that is no dollars. So I think the only one we were missing, yeah, we didn't have any interval data. Which makes sense, yeah, things like time and temperature. Interval, it's one of those things, I think it really usually is only time and temperature. So, which are fairly easy to work with, but. Yeah, so I believe in your discussion, yeah, so in your discussion post for this week, you're going to have to be able to find data and then characterize it. So in terms of, is it categorical, numerical, nominal, ordinal, interval, or ratio? Okay, so let's do another little exercise. So we're kind of moving away from, yeah, you've already done this in discussion, but I'd like to do it together as well. So now I want to observe how you think like a data scientist. So consider your day-to-day activities. Like when you're on the internet, you interact with family and friends, watch sports, play games, go to the store. Are there things that you have observed that kind of make you say, well, I wonder why that is happening? So go ahead and think for a minute and choose an observation, something that is interesting to you about just stuff that's happening in your everyday life. Why is it interesting to you? Why might it be interesting to somebody else? And then try and develop a research question based on your observation. Okay, so does anybody have an observation that they would like to share? This could even be from your previous discussion, if that makes it easier. Yeah, what's up?
Mobile games, like any game, what we play, like we can make an observation what is making interest in the game.
Yeah. Okay. So, well, yeah. First of all, I really enjoy video games. So it's an easy topic for me. Yeah. I guess you could say, why does this interest me? Is one question. So can you give me an example? Like, so what's a game that you're playing? You say, oh, I'm enjoying this because.
If it is some racing game,
Okay.
if I have more towards sport cars or bikes.
So not Mario Kart.
Then I like those games.
Okay. Like
That would be my observation. Like if some people like this kind of things, they like those games.
Yeah, actually, that kind of, you haven't read my paper. Just kidding. So no, that's actually a good question. At one point, I tried to, and actually kind of successfully, was able to tell, based on the kind of games that people enjoyed, what sort of problem solver they would be. So if you think about like first-person shooter, what I found was that those people, they're very good at solving problems that are well-formed. So they come into a puzzle game, for example, they try to clear the room. That's what they do. Clear the room, clear the room, clear the room. But they have trouble maybe thinking kind of outside of the box. Again, this is generalization, but they're so focused on like what's in front of them in the room that they're not seeing sort of the bigger picture. Whereas maybe somebody who enjoys puzzle games, they are able to push through more difficult situations and kind of see a bigger picture. That's not what he's great. Yeah, okay, so going down the line, the main idea here is, why is this observation interesting to somebody else? Because the hope would be that you're able to investigate a problem that can be generalized for a large population. And take the case of video games, that's one thing. But if certain people enjoy a certain type of product for a certain reason, then that's something that could be profitable. So I'm trying to think of another good example, just day to day. You guys are such heavy analysts that maybe you don't just kind of stop and think, why? Was that, out of curiosity, was that a hard thing for you to do? Just sort of think like a scientist? Or no? No, okay. So you guys are real philosophers. That's what I actually got to laugh. I'm sorry, it's been such a long time since I've taught like in person for an extended period of time. It's just a strange thing, and sometimes not very many people show up. So I appreciate that. And if you come back, I'll make sure to have some more interesting activities for us to do. So, but yeah, so once you've zeroed in on why it might be important to somebody else, then you can start to develop a question. So like, in the case, I'll take the video games again. So my research question was, can I observe somebody playing a game in particular and determine where that person should be in an organization? Like what kinds of skills do they have that would be suitable? That kind of thing. And then for this week, how might you answer the question you're posing? That's where we start to look at all the different types of analytical techniques, like statistics, like data mining, etc. So, okay. Well, I'm glad that this exercise hasn't been too challenging for you. I think it just depends also on the group of students.